Hey everyone, welcome back to another video for Quill Academy. So in this video we are covering overflow and underflow vulnerability in smart contract. So let's start with basically what is overflow or underflow vulnerability and why does it occur. So overflow or underflow happens when an arithmetic operation reaches the maximum or minimum size of a type. So in Solidity we have unsigned integer. So we have different types of it, such as 8 UINT 8, UINT 16, UINT 32, 64, and so on until UINT 256. So each thing has a maximum amount of value which it can hold and a minimum value. For UINT 8 we have 255. For UINT 16 we have 65,535, and for UINT 32 we have this figure and so on, right? So when we do some calculation which will exceed the value for the integer, it may there will be an overflow or underflow vulnerability. So let's see that how it's calculated. So we have taken an example of UINT 8. So here we have 8 bits, and if we calculate using this formula, or it's a very basic formula, we get 255. That is the maximum value which UINT 8 can hold, right? So in the same way we can find out the minimum value which a UINT 8 can hold by the same formula. We just need to replace 1 with the 0 and we get 0. So UINT 8 can hold, the minimum value it can hold is 0 and the maximum it can hold is 255. Now and if we try to add any number to 255, which is the maximum capacity UINT 8 can hold, it will cause an overflow vulnerability. So let's see this example. So we have an example over here of UINT 8 balance, that is 255. So we have initialized the balance to 255, and then we are increasing the balance with 1, right? So balance plus plus basically means balance equals to balance plus 1. So we are increasing it by 1, but as 255 is the maximum value this thing can hold, so it will cause an overflow and it will return 0. And in case of this one, in this case it will cause an underflow vulnerability because we have initialized the balance to be with the value 0. Now if we subtract anything from 0, that is the lowest value UINT 8 can hold, so it will cause an underflow and it will return the maximum value for UINT 8, that is 255. So basically I hope it's clear, and let's move on to practical exercise where we will be exploiting the vulnerability and looking at how we can mitigate this thing, right? So let's start with this. Okay, so we have a very basic contract for the token. Here we have a total supply which tracks the supply for the token. Then we have balance which maps address to the number, and then we have two functions over there. The first function is add token and the second is subtract token. If we call add token and pass in any amount, it will update the balance of message.sender to with the amount, and also it will increase the total supply with that amount. And if we subtract the thing, so it will subtract from message.sender and same with the total supply. Now we can see that we have UINT 16 over here, and the maximum value UINT 16 can hold is 65,535, and the minimum value should be 0, right? So let me correct here. Okay, so let's deploy it and try to exploit the overflow and underflow vulnerability over here. Let's first deploy the contract itself. So here we have successfully deployed it. Now where can we cause overflow? So let's take an example. We have add token. We have added the token for this amount, that is 65,000, which is the maximum thing, right? So the total supply is 65,535, and if we check the balance of our address, that is the same. Now it is the maximum capacity, right? So if we just add one more token, it will cause an overflow and it will return the minimum value, that is 0. So let's try it out. If you call the add token function and again try to call balance, we can see that the balance has become 0 and the total supply also is 0, because total supply can also hold UINT 16, right? So it's 65,535, right? So we have successfully exploited the overflow vulnerability. Now let's look at the underflow vulnerability, right? So in subtract token we can cause an underflow with it. So currently we have 0 for total supply and the balance is also 0. Now if we try to subtract 1 from the minimum value, that is 0, it will cause an overflow, it will cause an underflow and it will return the highest value for this one. So if we try to subtract 1 from the balance, we can see that it's returning the 65,535. That is the highest value, right? So we have successfully exploited the both overflow and underflow vulnerability. Now this is basically what it is, and now let's look at how can we mitigate the vulnerability. So this vulnerability was this vulnerability can easily be mitigated using SafeMath library or using Solidity version more than 0.8.0. So here we are using 0.7.6, so it's vulnerable to overflow, but from 0.8.0 this has been already mitigated. So let's try to change it to 0.8.6 and try to exploit the same vulnerability once more. Okay, so let's say we have added the maximum token, and yeah, we have that thing, and now let's try to add one more. Okay, I don't know what is happening. There might be some sort of issue with it. Okay, so now we have deployed the contract, and let's try to add 1 to it, and let's check the total supply. Okay, so it's 2, so we have added that. Let's try to decrease the 2 and we have total supply 0, right? So let's try to make it underflow by calling the subtract token function, and we can see that it isn't happening because the transaction has been reverted as from Solidity version 0.8.0. It has been auto mitigated. Still, if we are using the lower version, we can easily mitigate the vulnerability using SafeMath library. But as of now, Solidity 8.0, most of the project use that version or more. So that is probably the best mitigation for this vulnerability. But if your project has some older version, you can also use the SafeMath library. You can simply import it using OpenZeppelin safemath.sol, and you can remove this plus equals to, and you can add function, and yes, you can do it. So basically this was it for this video. We understood the overflow or underflow vulnerability. We practically exploited it, and we also discussed about some measures on how do we mitigate it. So that's all for this video. Thanks for watching. We will be soon launching some new videos on more vulnerabilities like access control, signature replace. Till then, subscribe to Quill Academy, like, share and follow. That's all. Thanks a lot.